Never grind again here at Prima Power Laserdyne. These big industrial lasers are proven to have the precision and the power to make manufacturing miracles come true. Let's get into it first thing with precision. Now here at weld.com, we've only scratched the surface when it comes to lasers and mostly handheld stuff. When it comes to something as industrial as this laser here, I'm with Mason Bongers. He's gonna give us a much more technical explanation as he's the application engineer for this piece of equipment.
What we have here is a 12,000 watt QCW laser.
QCW, what's a QCW mean?
Quasi-continuous wave.
That sounds like science fiction.
It does. So when you turn the laser on, most people just imagine a solid amount of power. You turn on the laser and you command 1,000 watts of power. What quasi-continuous allows you to do is allows you to pulse. So instead of just turning it on at 1,000 watts, you can just pulse 10 times a second at 10,000 watts.
Well, who wants this for as a customer? What application is it typically for?
The aerospace industry. So we do those.
Air and space.
Yes.
Okay. And when it comes to precision, like how small of a weld or hole can you make with these types of machines?
So when you're talking about hole sizes, the smallest hole we can make is roughly 7 to 8 thou.
Tiny, real tiny, right? Okay, so how fast can you put a tiny hole like that? I mean, does it mess up anything?
Just recently I was doing an application, 68,000 holes, and I was doing about 50 holes a second.
That is crazy to think about. Now, what is the biggest challenge that it has when it comes to getting the right part and having consistent pieces coming out?
So lasers are flexible. You can do drilling, you can do cutting, you can do welding, you can do scribing. Fixturing is critical. If you don't have a part fixtured well, it won't cut, drill, or weld as well as you need it to. So, yeah, as you can see here, this is a very basic setup that we mocked up here in-house.
It takes a lot of time to make sure your fixturing's proper. How long did it take you to get this simple fixture to get perfect?
So this one, 8 hours.
8 hours, the whole workday of just piddling.
The tighter your parts are and the better your fixturing is, the less you've got to work on it.
Right, and that's the idea, right? To spend a lot of time in the planning phases before you actually start work. That way when work happens, it's just boom, boom, boom.
Press a button and weld.
So what is this proper? What if I just do this?
I would say, that's proper. You tilt it like this, we're out. You're not gonna get a good weld. These parts, tight tolerance. Our spot size is only 6 thou, so if you're 6/1000th of an inch away from your part, it's not gonna weld.
We've seen it have success. Let's see it not have some success. All right. Let's see it miss a joint.
And here we go.
Now, if the part is off, is there like any compensation that you can do?
Yeah, so you can always add, more probing routines that'll add cycle time, but lets you have a little bit more leeway with your fixturing process.
What about if you see that it's off, do you slap one of your buttons to say quit?
You stop right here, bam, that'll make it stop nice and easy.
What are some of the buttons that you do a lot more touching with over here?
Well, dry run's always one of them. It's the biggest button I press. That makes it so the laser won't fire while I'm running the part. Another couple ones are, fine jog. If I'm trying to do a nice fine adjustment, that fine jog button will make it so every one of these clicks will move it 10,000th of an inch.
Okay. All right, looks like the part's done. Let's check it out. I can touch it?
Go for it.
Okay, that's not spicy. Ah, I see, you missed it. Missed it by about 5 thou. Now, I gotta admit, Mason, it is very impressive the size that you did. And all it took was just a little bit of a skew by a couple thous you guys like to talk about, and you're just completely off. It's impressive the precision that it has, but it does take a lot of time to be precise on the front end so that the back end looks perfect, right?
Take a lot of work on the front end, program your part, make sure it's working properly, get you good results.
Now we're gonna dive into some of the other applications that these lasers can do. Let's go check on our man, Dallas. I'm here with Dallas Reed, another applications engineer here at Prima Power Laserdyne. Now, to the untrained eye, Dallas, this machine looks the same as the quasi over there. I think this one is a little bit more down and dirty, right? You can kind of just set that power and go, whereas the quasi, you really need to rely more on that pulsing because that's what the application's for.
So even though we're using a continuous wave laser, we can pulse it. It's just more limited with the peak power, but we can still get very good results with the ablation processes. It's very good at welding. We can weld through very thick material, get great penetration, great results. And it also does a good job of cutting, although a bit more limited with the specialty materials. And this also is a 200 micron fiber, so it has a lot larger of a spot size versus a 100 micron. So things like our perf width is going to be a bit thicker for cutting. rougher edges, but we'll also have a lot wider weld path when we're doing the same kind of focus.
What I'd like to see it do is do a little bit of strength testing. We're going to take that piece of flat bar, we're going to do the cleaning mode, right? We're going to get it all cleaned up, then we're going to punch a hole in it, right? We're going to use the cutting process, get a hole, super nice clean hole, as well as doing a little bit of the etching. Now the etching, your customers use it not only for markings, layouts of material, but they also use it as designations for dates or numbers, letters, left, right, up, downs, and all that kind of stuff,
Exactly.
right?
You can engrave dates, engrave parameters, anything that we want for traceability with we process materials.
Yeah, and then we're going to weld that nut on there, and then I'm going to put the hammer on you there, and we're going to do some durability testing on that weld that you just made. Let's do it. All right, Papi Chulo, let's see it, man.
All right, so we got our Swench wrench that can output 800 foot-pounds, and we'll see if we can.
How many hand pounds is that?
At least 5. I don't think it's moving.
Dude, you are just rounding it off. That seems like a pretty good strength test. How many foot-pounds you say?
About 600, 650.
That sounds like a lot. Let us know if that's a lot down in the comments. That seems pretty cool for just a simple nut on there. That sucker ain't going anywhere.
No.
Well, what I would like to see next is some of the challenges when it comes to welding any type of weldment and fit up. So can we do some experimenting when it comes to some fit ups?
Yeah.
Let's do it. All right, so I'm back over here with Mason. What unit is this, Mason?
This is 81151.
So we used the 1151. We wanted to try different fit ups and try to troubleshoot some different things that you might come across as a customer, right? We did our first one. It was tacked together first, and then we made that weld all the way across. It's pretty typical what you see every day. That's what you want.
Yep, nice, bright, shiny silver welds, tacking both sides just to make sure, you're not going to split the weld at all. We've gone over tacks in the past. This is just, making sure we got a nice, pretty weld, baseline, what we're looking for.
Right, and then the second one will happen to be if you had a couple nicks or blemishes on the part during the fit up, so we had the exact same fit. The only thing is we had a couple divots at different sizes across the joint. We noticed that the laser on the smallest divot was still able to jump across it, and we're really pushing the tolerances of those thous that we keep talking about in these videos. And of course we make it across the plate, that laser's gonna miss.
Once you start getting those bigger gaps, we can't push that weld pool any farther.
If you added some filler or had the capabilities of making a homogeneous weld, then you might could get away with a little bit more of a gap.
Exactly.
Right? Now, we wanted to see if distortion had any part to play with it, so we didn't tack this joint at all. It didn't do anything. It worked just as good as the first one.
Yeah, one of the few times I'm disappointed by how well the weld turns out. So when we see some of the higher power welding, we'll see a little bit more distortion happening in this material. However, this is just 2 millimeters thick, or 80 thousandths of an inch. And so with such low power, we're not seeing that distortion.
For sure. Now, we wanted to see that, so we set the jig up where we actually had good fit up to a wide fit up. When I say wide, how many thou is that?
Now, I'd say that's probably on the range of 20 thou, maybe half a millimeter.
Right, so when we got that, it started off just as it always has, and then it's just hitting those troubleshooting spots. It's trying to have material to weld, but obviously that's going to be the biggest issue, is a gap in the material.
Yeah, and as you can see in this, we are riding on one side of this seam, and it's melting that. It's just not completely filling across the weld.
Yeah, you can see it at the very end. It's kind of clear as day. It's on one side, but there's nothing to push it into, so it just kind of falls out.
Yep.
Right, and now I wanted to test as far as high-low, different levels. As long as that gap is tight, that little bit of high-low, we still had material to push into. It may not be what the customer wants as far as a fit-up, right? But
will it weld? Yes.
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 Still can't fill a gap just like I can with that TIG torch. I want to thank Laserdyne and Prima Power for having us out and get to play with all these really cool toys. I know you guys haven't met Chris yet, but Chris is the perfect man to talk to when it comes to telling you where to find all this really cool technology.
Well, definitely reach out to us at primapower.com. Look at the Laserdyne equipment. Definitely reach out and request our laser welding 101s and our laser process calculators. We have a lot of tools that we can give you guys free of charge, whether you have our lasers, you don't have our lasers. It's just good, useful information so you can learn more about the process, more about the product.
Awesome, man. Again, thanks for having us out, Chris.
Absolutely.
Man, it's been a pleasure. We'll see you guys on the next weld.
Welcome back to your favorite show, Will It Laser. Today we're going to see, can a machinist vice stand up to a very powerful laser? Let's see. It's putting up a fight. It's putting up a fight. It's very bright.
Oh God.
I'd say yeah.